Alright, last problem for this set. We've got a soccer ball rolling due east at a certain speed, and it gets kicked, changing velocity to 6 meters per second due north. We want to find the magnitude and direction of the impulse on it. So, the key thing to recognize here is that this is a vector problem. It is two-dimensional, so there's the ball with a mass of 1 kilogram, we'll say. Well, that's not 11 kilograms, sorry. 1 kilogram, there we go. And it is rolling due east. We'll just call that, speed of u. Okay, and then it gets kicked. So there's a foot, and it goes bump, 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 and then it's moving due north at a speed of v. So, what is the magnitude and direction of the impulse that acts from the foot? So, basically, we have to remember here that impulse is change in momentum. So we have to find the momentum before the kick and the momentum after the kick as vectors. So the momentum before, so for this thing here, P is going to be m times the velocity before. Now it's velocity. I'm going to set up your standard sort of x-y coordinate system. So x going east and y going north. And this velocity here is just all in the positive x direction. So this is just m times u times I hat. So velocity is u I hat. Multiply that by m, there's your momentum. Okay. Afterwards, your momentum is all in the j hat direction. So it's m v vector, which is m times v speed j hat. Okay, so and P before. Okay, so delta P I equals delta P equals final momentum minus initial, so after minus before, and that equals mvj hat, equals mvj hat minus mu I hat, and that is going to equal m times, let's see, negative u I hat plus v j hat. Simple enough. Magnitude of that is going to be, so let's see, magnitude of the impulse vector is going to equal m, I'm just going to pull this out of the whole squared and square root thing, square root of u squared plus v squared. We can't find that out without, without actually having numbers for u and v, but there you go. And then the angle is going to be, so that it looks like our impulse vector is going to be, there's your x, there's your y, and our impulse vector is going to be going in the negative u direction and the positive j. And this is going to be v here and u. So there we go. It's that angle. So this angle is going to be the arctan. Why is my thing not working? Okay. I don't know. The hard drive is thrashing now. So it's going to be arctan of negative u over v, whatever. Okay. So, let's go and plug this in. Let's see there we go. Okay. 2 meters per second, 6 meters per second, and the mass with a course of 1. Okay. So, 1 times square root 2 squared plus 6 squared. Hope you can still hear me. That's going to equal 6.32. 6.32 is our magnitude. We'll do that, and then our this is going to be arctan of 6 divided by negative 2 y over x, right? So that. And that gives us negative 71, but that's an angle below 0. So we actually want to add plus 180 to that. And So it's going to be 108 degrees for our angle. And we got that correct. So you can see instead of negative 71 was down here, would have been an angle down this way, but we wanted to have 108. So that's what we got. And that's our answer.